Sunflower oil is one of the most widely used cooking oils in the world, valued for its neutral flavor, high smoke point, and versatility in everything from home kitchens to large-scale food manufacturing. But behind a simple bottle of golden oil is an industrial process that begins in open fields and ends on high-speed bottling lines. What starts as a hard, dry seed is transformed through mechanical force, chemistry, heat, filtration, and precise quality control into a clear, stable oil that must meet strict food safety and consistency standards. And today on The How Factory, we're stepping inside massive processing plants to see exactly how sunflower oil is extracted, refined, and bottled at scale. The story of sunflower oil begins with the sunflower plant itself. Native to North America, sunflowers were originally cultivated for their seeds long before they became a global oil crop. As industrial food production expanded in the 19th and 20th centuries, sunflower seeds gained attention for their high oil content and favorable fatty acid profile. Over time, selective breeding produced varieties optimized specifically for oil extraction, with larger seeds, thinner hulls, and higher yields. Today, sunflower oil production operates on an agricultural and industrial scale, supplying millions of tons annually. The process starts long before oil extraction, with harvesting and seed preparation. Mature sunflower heads are harvested using combine machines that separate the seeds from the plant material. These seeds are transported to processing facilities where the first priority is cleaning. Incoming seeds often contain dust, stones, plant debris, and broken fragments. Cleaning systems use vibrating screens, air classifiers, and magnetic separators to remove contaminants. This step is critical, as foreign material can damage equipment and contaminate the oil. Once cleaned, the seeds are dried to a specific moisture level. Moisture control is essential. Too much moisture reduces oil extraction efficiency and promotes spoilage, while overly dry seeds can fracture unpredictably during processing. Large drying units gently heat the seeds while circulating air, bringing them to optimal storage and processing conditions. After drying, the seeds are stored in silos until they are ready for crushing. Before oil extraction begins, sunflower seeds typically undergo dehulling. The outer hull contains little oil and contributes unwanted fiber and pigments. Dehulling improves oil yield and quality. Mechanical dehullers crack the seeds, and air separation systems remove the lighter hulls from the heavier kernels. The kernels, now rich in oil, move on to conditioning. Conditioning prepares the kernels for efficient oil release. The kernels are heated slowly in stacked, steam-heated chambers. This controlled heating softens the cellular structure and allows oil droplets to flow more freely. Temperature is carefully regulated. Excessive heat can degrade oil quality, while insufficient heat reduces extraction efficiency. The goal is to reach a point where the oil can be released with minimal resistance. Next comes mechanical extraction, often referred to as pressing. The conditioned kernels are fed into large screw presses. Inside these machines, rotating screws apply increasing pressure, squeezing oil out of the crushed seed material. The oil flows through small openings, while the remaining solid material exits as press cake. Mechanical pressing extracts a significant portion of the oil, but not all of it. The press cake still contains valuable oil that must be recovered. To maximize yield, most large-scale operations use solvent extraction after pressing. The press cake is broken into small particles and fed into extraction vessels. A food-grade solvent, typically hexane, is used to dissolve the remaining oil. The solvent oil mixture, known as micella, is separated from the solid meal. The meal is then heated to evaporate residual solvent, producing a protein-rich byproduct commonly used as animal feed. The micella moves to distillation systems, where heat and reduced pressure separate the solvent from the oil. The solvent is condensed and recycled back into the extraction process, while the crude sunflower oil continues forward. At this stage, the oil is dark, cloudy, and contains impurities such as phospholipids, free fatty acids, waxes, pigments, and trace metals. Refining is required to make the oil suitable for consumption. Refining begins with degumming. Crude oil is mixed with water or acid solutions to hydrate phospholipids, which then become insoluble and can be separated by centrifuges. Removing these gums improves oil stability and prevents foaming during cooking. The separated gums may be further processed for use in food additives or industrial applications. After degumming, the oil undergoes neutralization. Free fatty acids contribute to off flavors and reduce shelf life. In this step, a mild alkali solution, usually sodium hydroxide, is mixed with the oil. The alkali reacts with free fatty acids to form soap stock, which is then removed by centrifugation. This step significantly improves flavor and stability. The next stage is bleaching. Despite its name, bleaching does not involve whitening agents in the conventional sense. Instead, the oil is mixed with natural bleaching earths or activated clays that absorb pigments, oxidation products, and trace contaminants. The mixture is heated under vacuum and then filtered, leaving behind clearer, lighter-colored oil. Bleaching also improves oxidative stability by removing metal traces that can accelerate rancidity. Winterization may follow, especially for sunflower oil intended for refrigeration or salad oils. Sunflower oil contains natural waxes that can crystallize at low temperatures, causing cloudiness. During winterization, the oil is slowly cooled under controlled conditions, allowing waxes to crystallize. These crystals are then filtered out, producing a clear oil that remains transparent even when chilled. The final refining step is deodorization. Deodorization removes volatile compounds responsible for odors and flavors. The oil is heated to high temperatures under vacuum, while steam is passed through it. Volatile compounds evaporate and are carried away with the steam. Despite the high temperatures, vacuum conditions prevent significant thermal degradation. The result is a neutral-smelling, neutral-tasting sunflower oil. Once refined, the oil is cooled, filtered, and transferred to storage tanks. At this point, quality control becomes critical. Samples are analyzed for color, acidity, moisture content, oxidative stability, and sensory characteristics. Laboratories use chromatography and spectroscopy to verify purity and compliance with food standards. Only oil that meets strict specifications is approved for bottling. Bottling begins with container preparation. Bottles, whether plastic or glass, arrive in bulk and are cleaned with air or rinsing systems. They move along conveyor lines to filling machines. High-speed fillers dispense precise volumes of oil into each container, minimizing oxygen exposure to preserve freshness. Caps are applied immediately and seals are checked automatically. Many bottling lines operate at remarkable speeds, filling and sealing tens of thousands of bottles per hour. Labels are applied, date codes are printed, and bottles are packed into cartons. Automated palletizers stack cartons efficiently for transport. Throughout the bottling process, sensors and cameras monitor fill levels, cap integrity, and labeling accuracy. Behind the scenes, sanitation and safety systems operate continuously. Oil processing equipment is designed for clean-in-place procedures, allowing thorough cleaning without disassembly. Fire and explosion prevention systems are critical in solvent extraction areas, where strict controls manage temperature, pressure, and vapor levels. Worker safety and food safety standards govern every stage. Sustainability plays an increasing role in sunflower oil production. Solvent recovery systems minimize emissions and waste. Energy-efficient heat exchangers reclaim thermal energy from refining stages. Byproducts such as hulls and meal are reused as fuel or feed, reducing overall waste. Some producers invest in renewable energy to power operations and reduce environmental impact. What makes sunflower oil production remarkable is the scale and precision required to transform an agricultural product into a standardized global commodity. Each step, from seed cleaning to deodorization, must operate within narrow tolerances. Small deviations in temperature, moisture, or chemical balance can affect flavor, stability, or yield. From harvested sunflower seeds in massive presses to solvent extractors, refining towers, and high-speed bottling lines, sunflower oil production is a continuous, tightly controlled system built for efficiency and consistency. And that is how sunflower oil is extracted, refined, and bottled at massive scale. turning tiny seeds into a clear, reliable cooking oil used around the world. Thanks for watching The How Factory.